Hi folks, I thought I'd put together a quick video to augment what I've already got in the content area of the course, just to make sure that everybody's clear on how the logic works here when you're completing the early start, early finish, late start, late finish times on a project schedule. From the reading, I think you get the point that sometimes the early start, early finish approach is sometimes called the forward pass, and the late start, late finish is sometimes called the backward pass. And we'll see the logic in each and how that derives the slack in the schedule, and then to identify those activities that will define the critical path. I'm not going to do this. I'm just going to do a few. What I want to do is I want to point out the probably the high anxiety moments here in this thing. I think most of it's pretty straightforward, but I want to just get to a point on the forward pass, and I'll explain why, and then on the backward pass, and I've got a value here that's not computing, and I want to explain to you why very quickly, just in case you're having the same problem. So on this forward pass, the early start, early finish, I've already done this, but I'll show you the cells and how this all computes. So note that activities A and B do not have any predecessors, so they can both start on day 0. And so if activity A starts on day 0 and has a duration of 3 days, it will finish on day 3. So notice what I have put in this cell is just equals whatever I have here. Just in case you want to change these times, this will still compute for you. And then the same thing for activity B. It can start on day 0. It will finish on day 3 according to the value that's in cell E13. Then let's see, as I get to cell or to activity C, notice it has a predecessor of A. So the earliest it can start is when A finishes. So notice I have put in here, I have referenced cell I12. And then the finish time will be I12, the start time, plus the duration of 7 days. So that's how I'm getting 10 here. So H14 plus E14. Same idea here. This starts on day 3, and then I'm adding the duration of 10 days to get 13 days here. So this all follows the same approach. So this starts on day 3, which is when activity B ends, and then it ends on day 8. So you can follow all that logic all the way down. What I wanted to get to is I wanted to get to a point where I have an activity that has 2 predecessors. And obviously, at least on the forward pass, activity I cannot start until B and H are done. So activity I will not start until whichever activity finishes the latest, either B or H. So notice this is where probably the key point is on the forward pass. Notice what I have in cell H20 for the early start time for activity I. What I have taken, if you go up here and look, I've taken the maximum of I13, which is the point at which, or the day, or the time at which activity B ends, and I've taken the max of I13 and I19, and I19 is the early finish time for activity H. And so, excuse me, with that math, obviously Excel is going to start activity I on day 47. And then the duration over here, I have, let's see, H20 plus E20, so 47 plus 15, that gives you 62. So I think the only other time you get into that, actually, you only have one other episode of that here, and that will get towards the end of the project. So you can go ahead and keep moving along with that logic, and you can fill this out, and you can finish up all the early start and finish times. One point I'll just make, the duration of the project is 68 days, so if you don't come up with 68 days, you made a mistake. What I'm also going to tell you is it's somewhere in here where you will find the maximum or the actual duration of 68 days. It's actually just so happens that in this project, it is not activity W. It'll be somewhere in this area, and it will be 68 days. So again, that's kind of the forward pass, or how you come up with the early start and finish times. Now on the backward pass, we're going to do almost the same thing, but we're going to go backwards. And there's one point of logic that gets reversed when we get to this idea right here, but we do it in a backward fashion. So activity W the duration is 68 days. It can end on day 68, and then since it has a 5-day duration, the math in this cell is K34, which is the late finish time minus the duration. And notice that when I put that in here, I get an error. And what's happening is if you go click on the cell, there just so happens to be an extra space before the 5. So if you just delete that, it should calculate just fine. And you may actually run through that or see that here in some of these other values. In some cases, I think there were some spaces in front of these values. So make sure you delete those if you're not getting Excel to calculate for you when you put in these formulas. So now I'm going to go to the next go from W to V. And here's the thing that you've got to look for when you do the backward pass. And this is why it's probably a little more challenging. If I look at activity W, what I want to check is, does activity V impact activity W? And you will notice activity W does not have activity V as a predecessor, so there is no impact. So this can also start on or finish on day 68. And then the late finish time will be 68 minus the activity time, which we must have another space here. I'm glad I'm doing this so you can all see this if this is not calculating for you. So day 65. So then the same thing. So now I'm looking at activity U and I'm looking at V and W, and do either V or W have U as a predecessor? It does not. So let's see, this activity U can finish on day 68, and then let's see, it has to start equals 68 minus 5, and we've got another value, and all we got to do is go here, and if we take out that extra space, we'll be in good shape. Same idea. Let's see, so activity T, do U, V, or W have T as a predecessor? It does not. So this can end on day 68, and then equals 68 minus the duration of a day. And of course, we're getting all of these lazy characters out of here for us. Activity S, as I look at the activities that come after it, is S a predecessor? It is not. So it can also finish on day 68. And then 68 minus this duration of 3 days. We'll go take out another lazy character here. Now we're also, so I think we're now at the point. So here is the magic. Here is the magic on the backward pass. We are now at, let's see, we're now at activity R. Actually, sorry, I'm early. I'm sorry, I was looking at something else. So you can disregard that comment. No interest at this point. So notice that activity R is not a predecessor. So day 68, sorry, that's 68, and then equals 68 minus 1 day, and I see a lazy character there as well. Now, activity Q. Is Q a predecessor? Does not appear to be. So it can finish on day 68 and then equals day 68 minus the duration of 3 days. And that should give us a late start time of day 65. Almost there, folks. Bear with me. I want to make sure I get to this point here where I show you where the fun comes in. And I think we're actually here now. So notice that activity P is a predecessor for a number of different activities. And so in order for P to be a predecessor of activity R, activity U, activity V, and activity W, it has to finish before any of these activities start. And so we see all the start times for all of those activities. So if I look at the late finish time for activity P, it's actually going to be the minimum of, let's make sure we catch all the right activities here, of activity R, which starts on day 67. and then activity U, which starts on day 63, and then activity V, which starts on day 65, and then activity W, which starts on day 63. So in order for activity P to be a predecessor of R, U, V, and W, it has to finish on day 63, right? In order to feed, it looks like U and W both also start on day 63. So P has to start on day 63, and then the late start time will be equal to 63 minus the duration, not equals to, sorry, minus the duration. And then it has to start on day 33. So obviously, this is the same process that you're going to go through to finish up the backward pass. Again, the forward pass is typically a little easier, but you are literally reversing the logic when you go on the backward pass. But again, I wanted, and I'm sorry for all this kind of this preamble here, but I wanted to get to the point where I've got an activity that actually is a predecessor of a later activity, and we want to show how that works in order to make sure that this activity finishes up in time to start these others. The only thing left to do once you go through, once you have all the start and finish times, the next thing you want to do is compute the slack, and the slack will be computed by taking the late finish time minus the early finish time, and then any of these activities that would happen to have a 0 on them for slack, those will be the critical path. And I'm actually giving you a little bit of a hint here. I'll go through and make sure you have all the math in here, but if you do this correctly, the duration should be 68 days, and the activities that I have highlighted over here in the left-hand column should be the activities that you find that are on the critical path. So I hope this is helpful. This is explained in the book, but there is a little nuance here that is probably worth our time to go through. And again, I think the two big ideas for you are making sure that you understand, this forward pass nuance, and then the backward pass again when you have to really kind of reverse the logic, and sometimes that just seems to be a little bit more challenging than the forward pass. So I hope this helps. If you have any questions, let me know, and take care.